Okay, we are taping already. It's lesson 8-4. And this lesson is looking at more multiplication properties of exponents. So more multiplication. Let's get that centered. Properties of exponents. Okay, so let's review just real quickly on multiplying exponents that have the same base. When we had 3 to the 5th, and we multiplied that times 3 to the 4th, that would equal 3 to the 5 plus 4, which equaled 3 to the 9th. In this case, the first thing that we're going to look at is actually multiplying or raising a power to a power. So we are raising a power to a power. Okay, so what is this going to look like? It's going to look a lot like this. In algebraic terms, we would say a to the m raised to the n, and that's going to be a to the m times n. So let's put that in numerical terms. Let's just take an easy 2, and 2 raised to the 3rd power. I'm going to raise that to the 4th power. And so this becomes 2 to the 3 times 4, which is equal to 2 to the power of 12. Okay, so when we raise a power to a power, we are actually multiplying those exponents. So let's look at a couple of examples, just an easy a to the 4th raised to the 7th is equal to a to the 4 times 7, which is equal to a to the 28th. Okay, and let's go now a little bit, I should move that up so that you can actually see it. Okay, and let's just go a little bit more complex with our problem. We've got t squared, I hate t's, oh well, times t to the 7th, and we are going to raise that to the negative 2. Okay, what is important to note here is that only this t to the 7th is being raised to another power. So this becomes t squared times t to the 7 times negative 2, which is equal to t squared times t to the negative 14. And now at this point, I need to add these exponents. So this then becomes, and we'll just go down, let's go down to this next row, t to the 2 plus negative 14, which is equal to t to the negative 12, which then, of course, is equal to 1 over, I'm completely off now. Oh, there we go. 1 over t to the 12th. Okay, I believe you can see it there. Okay. Okay, so let me turn this page, and we will look at another problem. Let's look at a to the 4th squared, and multiply that times a squared to the 5th. So what's going to happen is this is a to the 4 times 2 times a to the 2 times 5, which is equal to a, going right the heck off there again, a to the 8th times a to the 10th, which is now equal to a to the 8 plus 10 equal to a to the 18th. Okay, so hopefully that is making real good sense to you. Okay, so let's move on to just expand this whole idea a little bit. And now what we're going to do is we're going to raise a product to a power. I'm going to raise a product to a power. Okay, so a product, you've got to know what a product is. Product is when you take two numbers and you multiply them together, you get a product. Okay, so we're going to have a product and we're raising that product to the power. So algebraically, let's say we've got AB, and we're going to raise AB to the n power. This, the A times the B, this is a product in here. And this n actually gets distributed to both items within that product. And so this is going to be A to the n, B to the n. Okay? So let's look at that and let's see how it actually works. So let's say we've got 2x to the 4th. And 2x raised to the 4th. This is going to be 2 to the 4th, x to the 4th. And because we've got this kind of situation going, I'm going to go ahead and say, well, 2 squared is 4 times 4 is 16. So this is going to end up being 16x to the 4th. I'm actually going to multiply that out. Hopefully that is making sense. Let's do 4g to the 5th. We are going to raise that to the negative 2 power. Okay, so once again, don't forget this negative 2 has to apply to both items within here. So this becomes 4 to the negative 2, g to the 5 times the negative 2. So this becomes 4 to the negative 2, g to the negative 10. And both of these having negative exponents, this means that they don't belong where they are. We need to make sure that we are working with only positive exponents. So I'm going to put them both in the denominator. 4 squared is 16, and g now to the 10th. So we have 1 over g to the 10th. Now let's go ahead and once again, let's expand this. Okay, and we'll do a couple of exercises that are a little bit more complex. So let's do, let me move my book so that I can actually read them a little bit easier, not much. And of course, it's probably going to fall into my video. So let's see, I've got c squared, in parentheses, I've got 3c to the 5th, and I've got this to the 4th. Okay, now c squared is just going to stay the way it is, so we're not going to worry about this so much. We do have to worry about this exponent of 4 and having it go to both of these. So this becomes c squared. Now, one of the things we haven't talked about is what's actually happening with this 4th. So I'm going to write it out. This c squared is going to be multiplied times 3, and that 3 has an exponent of 1 times that 4. Okay, we just need to make sure that we are aware of that times, and this is c to the 5 times 4. Okay, putting it all together, okay, we've got c squared, we've got 3 to the 4th, we've got c to the 20th, and now we have to combine these c's. That's c squared times c to the 20th. So I've got 3 to the 4th, oops, almost didn't make that a little exponent, times c to the 2 plus 20. And so that is 3 to the 4th c to the 22nd power. And 3 to the 4th, well, that's 3 squared plus 3 times 3 squared. So that's 9 times 9 is 81. So we've got 81c to the 22nd. Okay. Okay. I actually, quite honestly, wrote the problem down wrong. But it still works out perfectly for us. We are absolutely fine. Okay, so let's look at the next problem. Hopefully I won't write it down improperly. 2a cubed to the 5th, and that's times 3ab squared cubed. Okay, so the first thing I do is I'm going to assign everybody to where they need to go. So I've got 2 to the 5th. I've got 3 to the 3 times, oh, that's an A. I am making bloopers all over the place today, and yeah, I know I don't know how to pull that out and make it a blooper reel. 3 times 5, okay, and then on the next one, so that's the first one here, and then I've got 3 cubed, A cubed, and B 2 times 3. Okay, so notice how I gave the 5 to the 2 and to the A cubed. The 3 goes to the 3, the A, and the B, all 3 of those. And now I'm going to just kind of rewrite everything so it's pretty clear. 2 to the 5th, this is A to the 15th, this is 3 cubed, this is A cubed, and this is B to the 6th. Now I know I can combine these two things and I can combine those two things. So so I know that I need to expand my constants. So 2 to the 5th is going to be 2 times 2 is 4, 8, 16, 32. So this is 32, and this is A to the 15th plus 3. This 3 to the 9th is 3 times 3 is 9 times 3 is 27, and B is to the 6th. Once again, we come down here and it's 32 times 27, and then we've got A to the 18th, B to the 6th, and when you do the math, I suppose we can go ahead and do that math. We've got 27 times 32. 2 times 7 is 14, 4, 5, 21, 2, 6, 7, 8, 4, 6, and 8. So we end up with 864, A to the 18th, and B to the 6th. Okay. We can do one more problem. Hopefully, I'm not making it too complex for you. We've got 6m, and that's cubed. And then we've got 5m to the negative 3 squared. So this becomes 6 cubed, m cubed, n cubed times 5 squared, and m, negative 3 times 2 is negative 6. Okay? So grouping these, I'm going to say 6 cubed times 5 squared, and then m, I'm combining 3 plus a negative 6, and then n cubed. So 6 times 6, 36, times another 6, 6, 3, that's 18, 21, 216. So this is 216 times 25 m to the negative 3 n cubed. 216 times 25 is 35, and that's 8 and 10. 2 times 6 is 12. 2, 3, and 4. Here I get 0, 8, and 2 is 10, and that's 4, and that's 5. So I end up with 5,400 n cubed, and I'm going to put that m where it belongs, which is in the denominator, and that will be our answer. I'm doing all the work by hand so that you can see what I'm doing, because I expect you to do it by hand also. Okay, hopefully that is pretty understandable. We will work on some problems tomorrow, and you can ask any questions at that time. Okay?